Okay, I had a little technical difficulty, so I'm skipping ahead. What I'm doing here at this matrix is I'm multiplying negative 3r2 plus r1, so that makes this a 0. Okay, so if you look and see, that's not a fact. I've done this row operation. Okay, this is now my resulting matrix. I'm going to now do 2 more row operations. I'm going to do 2 times row 3 plus row 1, and that makes a whole row of zeros up here. Then I'm going to do r3 plus r2. That makes this a 0. This is still a 1, and it makes this a negative 3. So 1, 0, negative 3, 0, and then the last row stays the same. Okay, now we're ready to read off the information. This here says that x2 minus 2x3 equals 0. So x2 equals 2x3. This one here says x1 minus x3 minus 3x3 equals 0. So x1 equals 3x3. So x2 equals 2x3. x1 equals 3x3. It looks like we have everything in terms of x3. x1, x2, x3. Okay, well x1 is 3x3, x2 is 2x3, and x3 is x3. Factor out the x3, and I get 3, 2, 1. Okay, so this is my vector or eigenspace for lambda equals 1. Okay, now I'm going to do lambda equals 2. So if lambda equals 2, I'm going to have a 2 here. So let's put a 2 here. And this matrix now becomes, I'm going to subtract 2 from the diagonal. So I'm going to do 2 there, negative 5, 1, 1, negative 2, negative 1, 0, 1, negative 3 times x1, x2, x3 equals 0, 0, 0. All right, let's get the augmented matrix and start solving it. Okay, my augmented matrix is 2, negative 5, 1, 0, 1, negative 2, negative 1, 0, 0, 1, negative 3, 0. First thing I'm going to do is I'm going to make a 0 here. I'm going to multiply by negative 2 and add it. So I get 0. When I multiply by negative 2, let me write that step in. I'm doing negative 2 r2 plus r1. Okay, negative 2 here makes a positive 4, and I add that, I get a negative 1. Multiply by negative 2 here, I get a positive 2. Add it, I get a 3. The rest is the same. Okay, let's now notice that if I add the third row and the first row, it becomes 0. So let's do 2 steps here. We're going to do row 1. Let's do row 3 plus row 1. And then I'm also going to make a 0 here. So I'm going to do 2 row 3 plus row 2. I have 0, all zeros on the top. The second one becomes 1, 0. Okay, when I multiply this by a 2, I get negative 6, and I add that, I get a negative 7. When, and then the last row stays the same. 0, 1, negative 3, and all 0. Okay, I'm ready to solve my equations. This one here says x2 minus x minus 3x3 equals 0, so x2 equals 3x3. x2 equals 3x3. And this equation here says x1 minus 7x3 equals 0, so x1 equals 7x3. Okay, so let's look back at what we have. The vector I was interested in, x1, x2, x3, we were able to get each of these things in terms of x3. So I know that x1 is 7x3. I know that x2 is 3x3. And I know that x3 is just x3. So that's x3 times 7, 3, 1. That's the eigenvector. 7, 3, 1. I want to just attach the appropriate vocabulary to these things. These here are eigenvectors. Okay, those are the eigenvectors. This is the eigenvector for lambda equals 0. This is the eigenvector for lambda equals 1, and so on. 2 of this eigenvector. The eigenspace, the difference between the eigenvector and the eigenspace is this. So here's 3 dimensions. Where are 3 dimensions here? So let's just look at this. 1, 1, 1. So that means I go 1 in the x direction, 1 in the y direction, 1 in the z direction. So let's just depict it like this. Okay, there's the 1, 1, 1 vector. What's the eigenspace? The eigenspace is all multiples of this. So what you end up with is a line. There's a little vector here. It lives on a line, and that line goes in both directions. So here's your little vector right here. And that's the difference between the eigenvector and the eigenspace. The vector itself is the coordinates that gives you the little arrow. The space is the full extension.